Hello everyone, welcome to my presentation, PaaS on Kubernetes, Journey of Making Cloud Foundry Cube Native. Myself, I'm Rohit, and I work as a software engineer at SUSE. So firstly, I'll be talking about Cloud Foundry and about its components, and then I'll be covering about BOSH, which is used to deploy the Cloud Foundry components on top of virtual machines. Later, I'll be talking about operators that we have created, that is Quarks StatefulSet, Quarks Secret, and Quarks Job. These operators are used for deploying Cloud Foundry components on top of Kubernetes, that is containers, instead of using BOSH, that is virtual machines. At the end, I'll be showing a demo about how to deploy an application on top of Kubernetes using Cloud Foundry. So the short form is KubeCF. KubeCF is nothing but the combination of all these operators. For those of you who don't know what is Cloud Foundry, it is an open source platform as a service offering from the Cloud Foundry Foundation. In a platform as a service offering, you only manage your data and logic of your application. The rest of the aspects are taken care by the software, that is Cloud Foundry in this example. Another example of a PaaS offering is Heroku, whereas in an IaaS offering, you manage your runtime, load balancing, authentication until the OS layer. So a classic example would be AWS, Google Cloud. And in an on-prem, that is traditional IT, you manage everything from top to bottom. That is, you're not in cloud. So where does Cloud Foundry and Kubernetes relate? Both are used for deploying cloud-native applications, that is microservice architecture. But Kubernetes is more of a CaaS offering, as a container as a service offering. It doesn't take care of building and management of your application. You need to create service, deployment, YAML files, pod files, etc. Whereas in Cloud Foundry, building and management of your application is taken care of. Both do not support function as a service as of now, I guess. So there's a small gap here in Kubernetes that we want to fill using Cloud Foundry, and I'll explain how we have done that. Let's get a bit deep into Cloud Foundry. What is Cloud Foundry? It is made up of many components which take care of your application. Each component has a specific role in managing your application. For example, there's a component called router, which routes the request received to the specific app instance. And then building, deploying, lifecycle management, and also scaling and self-healing are all managed by Cloud Controller and Diago component. Logs and metrics from your apps are collected through log aggregated component, and UA handles your authentication and authorization. That is, you can connect to LDAP to your company's user directory. And finally, service brokers, which are used to connect your databases and external software solutions, software as a service solutions. Service brokers are needed here because you can only run stateless applications on top of Cloud Foundry. So if you want to connect to your data, you need to use service broker and then connect to the database. So the summary here is that Cloud Foundry is a PaaS software and is made up of many components which take care of managing your application. It's a software and it needs to be highly available and it should recover in a case of failure. It should have monitoring. It should have zero-time updates, because for all of your application, Cloud Foundry, that is the PaaS software, is the crux. This is where BOSH comes into the picture. It is used to deploy Cloud Foundry components on top of virtual machines, and it has all the necessary features to be highly available. So you can think of BOSH as a Kubernetes of VMs. Okay, so your apps too on top of virtual machines. So this was about Cloud Foundry and BOSH. So what is our goal? We at SUSE, along with IBM and SAP, under the Cloud Foundry Foundation, want to move away from virtual machines to containers. So all the components on the left side that you can see, router, UA, Diago, these are the components of Cloud Foundry traditionally deployed on virtual machines. So we want to containerize these and deploy as pods in Kubernetes nodes. Another interesting thing here is that whatever apps you deploy using Cloud Foundry will also be deployed as pods in Kubernetes, StatefulSet in particular. So our solution was to replace BOSH with a set of operators. Let's touch the basics of operator. Operator is I feel like it's the most flexible feature of Kubernetes, which is allowing everyone to build customized solutions on top of it. That is, building platforms on top of a platform that is Kubernetes. And I guess it is one of the reasons everyone is adopting Kube. What is an operator? An operator is a collection of a resource and a controller. There are many predefined resources in Kubernetes, such as pod, deployment, and replica set, etc. An amazing feature of Kubernetes is that it allows you to define CRDs, that is customer resource definition, which allows you to define your own custom resource. So we have created our own custom resource named Quarks StatefulSet, QuarksJob, and Quarks Secret, and the related controllers too. Next up, what is a controller? For each resource, there is a controller which takes care of it. For example, we create a replica set resource using kubectl create with the replica count 2. Then the replica set controller will capture this create event and then create 2 pods. So basically, a controller runs in a loop to match the current state in the cluster with the desired state, that is your YAML files. Okay, so this was the basics about operator. Now, as I said, our goal was to replace BOSH with operators, and we had to replicate all the features of BOSH. So we divided the features of BOSH into 3 sets and developed an operator for each set. Each operator is an extension of a particular resource in Kubernetes and has some additional features. I'll be touching upon the additional features of each operator now. The first one is Quarks Job. It is an extension of the Kubernetes job resource. The additional features here are that we support errands and storage of the output of a job pod in a secret. Errands are basically one-time tasks which a developer can run anytime. As you can see in the image, it has 2 extra fields, trigger and then output. And the rest of it is a job template. Let's see a quick demo of this. Okay, so we deployed our operator Quarks Job, that is the second one. And this is the custom resource Quarks Job. And you have trigger.strategy as manual right now, and the output map, it says I need the output of the job in a secret named foo.json. Let's change it to now. And then run it. Okay, you can see the job pod. It's running. Let's see if the secret is being created or not. Yep, and it has the output 2 key value ways that we outputted from the job. So this is a very simple operator, just an additional feature to run errands. There's another operator, Quarks Secret. It is also a simple operator which is used to generate passwords, certificates, and keys, and saves it as secret. It also supports rotation of these secrets. You can see there's a type field in the spec, and I've written it as password. That means I'm asking the operator to generate a password, and with this, store it in a secret named gensecret1. Let's see a demo of this too. Right now, the Quarks Secret is part of the CF operator pod. So I have the Quarks Secret custom resource with the type password. That means the password will be generated and stored in a secret. Let's check the secret. Yep. It has been created, and the password starts with the alphabet A. Now let's see rotation. Rotation is very simple. You just need to define a config map with a list of secrets that you want to rotate. In this case, it's generate password that we want to rotate. Let's create that. Now let's check if our password has been changed or not. It takes some time, so I'm skipping. Yep, so it started with a capital V. So you can, this operator can be used to generate secrets and rotate them. Next is Quarks StatefulSet. It is also an extension of the StatefulSet resource in Kubernetes. The additional features are that it supports AZ support, that is, basically it creates a stateful set in each of the availability zone. The next one is active passive deployment, which means if there are 3 replicas, then 1 replica will be active and other are passive. And if an active pod fails, one of the passive pods is made active. And Canary updates. Canary updates are good because you can recover from an update failure. I'll show how to recover from an update failure using Quarks StatefulSet now. Yeah. So this is a Quarks StatefulSet resource. From the spec, it's nothing but the StatefulSet spec, and we are putting the replica count as 3 here. So you'll see now 3 replicas pods being spawned. Okay, now suppose we have updated our application and made a new Docker image, and we want to specify that in the Quarks StatefulSet YAML. So we edit it. But we made a mistake, so the update fails. You can see the second pod is terminating and it will try to respawn. Yep, so you have seen the image pull error. Now you debug your application and find out that you made the you misspelled the name, so you correct it now. It's trying to update again. Yep, so it successfully updated the 2 and then it goes on updating the rest of the pods. So these are the basics. These were the basic operators that we have created, but the real Cloud Foundry and Kubernetes, that is KubeCF demo, I'll show you to now. Okay, so here you can see all the pods, KubeCF adapter, API, router, and all these. These are nothing but the Cloud Foundry components on top of Kubernetes as pods. So we containerize those components and deploy it on top of Kubernetes. Now, so the first 2 are the operators. Those are required to deploy the Cloud Foundry. Okay, so the first thing we have to do is we have to log in with the Cloud Foundry package. So I log in with the api.kubecf.suse.dev. Okay, so since this is a PaaS offering, Cloud Foundry, you do not create any role-based access users, that is cluster admin or anything. You have an inbuilt hierarchy structure, orgs, spaces, and users. Organization, you can see organization as your company, and then inside there's a team that is space, and then user would be the team member. And you can allocate quota for at each level so that they don't overuse the resources. So we have to create an organization first, and then target it. And then we creating a space here. Targeting it then. Right. So in a PaaS offering, I already told you that you need not take care of building and managing your application. The only thing you need to take care is the business logic, about the code. So I have a simple Python Flask application. I go into the directory and execute one single command. That is, before that, I write a basic manifest file. This is required for Cloud Foundry. You need to specify the number of instances and the build pack. The build pack is not necessary here. The Cloud Foundry will automatically detect the language that you wrote in and fetch that particular build pack, and the memory, and the many other options, health checkpoints, etc. Yep. So I go into my Python Flask directory and implement a simple command. CF push and the name of the application, and that's it. Cloud Foundry will take care of everything else. Now, you will see this is just a staging thing. Yep. So now you have seen that your application Python Flask is deployed as a stateful set in Kubernetes with replica as 3. So you didn't build your Docker image, you didn't write any service file or deployment YAML file. Everything is taken care of by Cloud Foundry, and you didn't create any role-based access, anything else. Cloud Foundry takes care of it. So that's a PaaS offering. Let's see some other benefits. Okay. Let's wantedly fail an instance. That is, we hit a /fail instance, then a particular instance will be failed. It will be crashed. So we'll do a curl, and then you'll see that on the top, the third pod has been killed, and it will restart immediately. Yep. So that's very simple, right? Just do a simple CF push, and then it will build a Docker image for you, and then deploy it in a stateful set in Kubernetes. So everything taken care of. No need to create any Helm charts or etc. So that was Cloud Foundry on top of Kubernetes. That's it. Yeah, the GitHub link is github.com/SUSE.QubeCF. Right now it's under SUSE, but later it will be promoted to Cloud Foundry Foundation in a few days. And we are active on Cloud Foundry Slack. Our channel is QubeCF Dev. Yep, that's it. I'm asked not to take questions here, but I'll be taking questions offline. Thank you.